everyone, welcome to my channel Math Monsters. This is the first video in our counting and probability series, and I'm super excited because it's probably my favorite math topic, and that's because it's so much more useful than most people think it is, and it's incredible how it works its way into real life scenarios. Today we're going to uncover questions like how many ways can I arrange a meal, or how many passcodes can I create? Plus, this is the kind of math that you see very often in contests like Math League, ANC8, and more, so it really is a fundamental step in the competitive math pathway. In today's video, we're going to cover two of the most basic but powerful tools, and that is the multiplication principle and the addition principle. So stay tuned, and we're going to use some example problems and step-by-step solutions to help us understand. And yeah, if you haven't already, please make sure to subscribe to the channel so that you don't miss out on any videos like this one. Hope you enjoy. Let's get right in.
Alright, let's start with something a bit simple. You have 3 types of sandwiches, 2 drinks, and 4 desserts. How many complete meals can you make? So basically, what the question is saying is that you've got 3 sandwiches to choose from, 2 drink options, and 4 dessert options. And the question is asking, how many different complete meals can you build if you have one of each? So basically what they mean by a complete meal is if you have 1 sandwich, 1 drink, and 1 dessert. Here's how you can think about it. For every sandwich you pick, you have 2 possible drinks you could pair that with. So just for the sandwiches and the drinks, you have 3 times 2, and that's because there's 3 types of sandwiches and there's 2 drink options. So say you picked 1 sandwich, then you have 2 possible drinks that you can pair that with. So if you have 3 types of sandwiches, you would have 6 total combos. And that's because 3 times 2 equals 6. And we're not done yet because that's just for the sandwiches and the drinks. We didn't start counting the desserts yet. Now, just like how we did times 2 when we counted the drinks, you would have to do times 4 when you count the desserts because there's 4 dessert options. So our total would really be 6 times 4, which is 24. Because there's basically 4 desserts you could pair the 6 with. So I hope that makes sense. The total number of complete meals you could make with those 3 components would be 24 meals. And this question was a classic example of the multiplication principle. And what the multiplication principle states is that when you have individual components, like in this case we had sandwiches, drinks, and desserts, and you want to find the total number of combos you can make with them, you would multiply the number of components you have in each. So just like how we did here, we did 3 times 2 times 4 because we have 3 sandwiches, 2 drinks, and 4 desserts. So that was a perfect example of a multiplication principle. Let's move on to a slightly different question. Let's look at another type of counting situation. This time, it's about making a single choice from 3 different groups. A student can either join 2 sports clubs, 7 academic clubs, or 2 music clubs. How many choices does that student have? If you think about it, it's actually a pretty straightforward question. Since we have 2 sports clubs to choose from, I'm going to write down 2. And along with that, we have 7 academic clubs, so I'm going to write plus 7. And finally, we have 2 music clubs, so that's another plus 2. And the reason we're adding here is because it's an OR question, and OR is a very important keyword that symbolizes addition. And this question actually uses the addition principle, and what the addition principle states is that when you're choosing one option, not many options, one option from multiple distinct groups, and you will only pick from one group, you can add the possibilities together. So that's exactly what we did here. We added 2 plus 7 plus 2 because those are our possibilities. If the question asked, how many different combinations can you make with one of each club, then you would do 2 times 7 times 2. Just like how I said you should look for the word or when you're doing addition principle questions, you should also look for the keyword and symbolizes the multiplication principle. So just remember that or means addition and means multiplication. So in this case, our final answer will be 11. So there are 11 different choices that the student has. Okay, let's move on to the next question. Okay, let's move away from food and clubs for a second and try something a little more abstract. But this is also super cool. It's one of those questions that's like super applicable to real life. We're trying to make a lock code. Say you've got 4-digit lock codes, and each digit can be anything from 0 to 9. And digits can repeat, and that's a super important detail in this question. So it's asking how many different 4-digit codes could we make? Well, let's start off by labeling our digit code, I guess, by drawing 4 lines for each digit. And there's 10 choices for the first digit. And I got that because there's 10 digits from 0 to 9. So the first digit can be anything from 0 to 9. And it would actually be the same 10 possibilities for the second digit as well. You're not losing anything for the second digit. Like say I chose 8 as the first digit. You could also choose 8 for the second digit because digits can repeat. So I could use the same 8 for the second and the third and the fourth if I'd like to. So I'm not losing any digit possibilities as I go forward in the code. So I would also have 10 possibilities for the third and 10 possibilities for the fourth. And notice how I'm repeating the word and that definitely shows that it's a multiplication principle problem. Even though and isn't in the question, when you're solving, you can definitely figure out that it's a multiplication problem, not an addition problem, because if you read it like 10 for the first digit or 10 for the second digit, that just doesn't make sense. So here we're going to be multiplying 10 times 10 times 10 times 10, which is 10 to the power 4, which is 10,000. Please excuse the red box. Okay, so we have 10,000 different 4-digit codes, and that's a lot. And this is one of those questions, like I said, where it's super cool to figure out the number of possibilities because it's extremely relevant to real life. And how cool is that? You can make 10,000 different possibilities just with 4 digits. So, yeah. All right, now let's step it up a bit with the more complex problem. It's one that mixes letters and numbers. Imagine you're creating a 3-character password. The first 2 characters must be letters A through Z, and the last one is a digit from 0 to 9. Also, we're told that characters can repeat, so you could have like AA3 where the A's are repeating, or ZQ9. Those are just some examples of passwords. Now let's break it down step by step. These are our 3 characters. The first spot must be a letter, so that's 26 choices because there's obviously 26 letters from A to Z inclusive. And just like in the previous question, repetitions can occur. So like if I had B for the first one, I could also have B for the second one. So I also have 26 possibilities for the second one. And since we have an and scenario, we will be multiplying the number of possibilities. So we have 26 times 26 so far. And for the last one, the third spot, it has to be a digit from 0 to 9. So that's 10 choices since there's 10 digits from 0 to 9 inclusive. So this could be like 8, just for an example. And now after we multiply all of this together, I know 26 squared is 676, and that times 10 is 6760. And that should be your final answer for how many passwords are possible.
And we have reached the end of the video. I really hope you enjoyed it and learned something new. The rest of the playlist will continue to be about counting and probability, but we'll definitely explore more and more types of questions. And yeah, stay tuned for those videos because I'll be linking them in the description box below so you can check those out. And yeah, have a great day. Bye.